Okie dokie. So this is Tuesday night's homework. We're going to run through it real quick. First thing I want to do is make a little space for me to work in. So if you give me 1 second. Let's select a nice color here. We'll just blank all this out. So that we've got some kind of workspace to fill in with math. Once again, anything I write down in black is stuff you should do. So anything I write in black I would consider part of answering the question. And anything I write down in blue, blue is just notes. Blue is me saying some things related to the topic that you wouldn't necessarily have to put on the page as part of your work. Once again, I'm going to assume you've already read this question. If you haven't, either hit pause or read your handout, because I'm just going to get right into it. The very first thing we have to do, any time we have a calculator active question, especially one that's a word problem, is just go ahead and type that into our y equals. On the calculator active, we'll put this in our notes. No derivatives. No antiderivatives. We don't want to do any of that. At least anytime we're given the specific function. If you know the specific function, we're not going to be doing any kind of work by hand. Maybe if it was a table or a picture, you might be doing some derivatives, but not with functions, right? There's not going to be any chain rule or product rule. It's all going to be magic button, right? We will be using this feature of our calculator quite a bit. Oh, erase my space. All right. Sorry. So I'm going to go ahead and just enter in this function into our calculator. And this function measures the amount of grass clippings that are in a bin, right? They're in this bin decomposing. So this isn't how many have decomposed, it's how many remain. Let's go ahead and enter it into our y equals menu. If this problem involved any trigonometry, we would want to check our mode also, but it doesn't. It's just exponential function, so mode doesn't matter. Seems pretty good. Okay, so we have it typed in. Anytime you have calculator active and you have an explicit function, you're going to do lots of kind of stuff in your calculator with that function, so it's worth it just to go ahead and get it in y equals where you can work with it. Okay, question 1. Find the average rate of change over the interval 0 to 30. So the average rate of change is that formula f of b minus f of a over b minus a, right? This is the average rate of change in f. An average rate of change is just kind of another way of saying, hey, the slope from point A to point B, right? The secant line slope. So it's basically the slope formula. Or in this case, what we want to do is say that the average rate of change from 0 to 30 is going to be a of 30 minus a of 0 over 30 minus 0. Believe it or not, it feels like we're like writing the formula, but this is really the work. The crunching of the number, that's where we're going to lean on the calculator. So we're going to go to our table, and we can actually use our table for all these values. A of 0 is 6.687, which is also kind of obvious because it's the starting value of the function. So we can say this equals, all right, we know we're going to have 30 in the denominator. We're going to have minus 6.687. And then we want to look up our value at 30. We can scroll down, or we can just kind of start off, jump to the 30 using table start. Okay, we got 0.78293. All right, I know I wrote that in there sloppy, but that's 0.78293. The last thing we need to do for the mathematics here is convert this to a value. So we're going to go back to our calculator, just kind of get over to our main screen. function. All right, get over to our main screen and let's type this in correctly. And type it in as a value. Oop. Always make sure your answer is accurate to 3 decimal places. I'm going to round up. And I think we're done with finding the average rate of change. We need to indicate the units of measure. So this is where we just take our y units and our x units, or our independent and dependent variable units, and divide them, and that's our units for our slope, right? It's the rise over the run. So let's see here. The units for A of t is a measurement of pounds. The unit of t is a measurement of days. So this is pounds per day. Boom, roasted. Okay, so that's A. Hey, just so you know, A is probably either worth 1 or 2 points. You get 1 point for not only having the right answer, but you also need to have somewhere on the page something that shows that you're doing slope. So if you write this out, that qualifies as showing slope. Or if you write this out, that qualifies as showing slope. So just some evidence that shows, oh, I found the total change in A over the change in time, and that was the average rate of change. So either of these plus the answer. And then the other point would be for the units, pounds per day. We're going to do B. I'm going to clear my screen and go ahead and redraw my workspace. Okay, find the value of A prime. So find the instantaneous rate of change. There is an app for that. We've already got it typed into our calculator, right? It already paid off going to our table. Going to our table really helped for doing average rate of change. Now, go into good old magic button, and we want to make sure our window, you always want your windows to include the value, so let's bump our window up, I think, to at least 20. That should cover 15. Oops, that's a minimum. And once our window is good, we can just go to our feature, and this right here, dy dx, right? That's another notation for derivative or instantaneous rate. So we're going to find our instantaneous rise over run somewhere over here at 15. If we recall, our earlier answer was around negative 0.19, and that kind of makes sense. If you look at the general slope here, you know, it's negative, negative 1/5 approximately feels right for that slope. Let's do our instantaneous slope. We've selected dy dx. We've typed in at that specific instant, it's actually this value. So how would we write this? I wouldn't just put the number, I would do some nice clear mathematical writing that A prime of 15 is negative 0.163. And then you can always do more. It doesn't hurt to go to a 4th decimal. You just have to do at least 3. Then we're going to use correct units. The units, we can go ahead and write them once. The units are still pounds per day. That's our units for the rate of change. Using correct units, interpret the meaning of the value. Okay. Anytime you're explaining the meaning of a derivative, there's some key words you always want to use. It's the rate of change. You always want to use that phrase. It's the rate of change. You want to have your units. So your units are always kind of your f of x units over your x units, or in this case, our a of t over t units. And you also want to use the independent and dependent values. So what that means is work the 15 somewhere in there as the independent value. Work that in. Work this number in somewhere as a dependent value. So say it's the rate of change, use the right units, reference this number, and reference this number. And that's kind of like the formula for kind of a good sentence explaining rate of change. And then the last thing you want to do is just add some context is correct. All right, so let's take a crack at how this sentence is going to go. Ooh, you know what, I tell you what, let's leave this number up here. And what we'll do is we'll just do some erasey. Be patient, I have a plan. All right, see, all better. All right, so what does this mean? It's the rate of change. The rate of change. Here's where we want to use some context. Well, what's happening in this story? In this story, grass is decomposing in a bin. So we can either, remember, that A is the amount of grass that's left. So we can either say that the rate that it is decomposing is this value, or we can say the rate for the amount left is the negative of this value. I tell you what, let's kind of take the negative and convert it into the word decomposing. So the rate of change that grass decomposes in the bin is this much. But remember, the word decomposing, that's the negative. So we want to say this is the rate it's decomposing. The rate including the negative is the rate for how much is left. So decompose is 0.1636 pounds per day at t equals 15 days. Believe it or not, the specifics that you write in your sentences and how many points they are worth are equal to the specifics for the mathematical work you do for things like question A. So always make sure you describe derivatives as rates of change. Make sure you know how to get those units right by using division. And make sure you have some correct context. So don't say like it's the amount of grass still in the yard, or it's the rate grass is added to the bin. Don't change the meaning, right? A of t is the amount of grass that is in the bin. So this is the rate it's decomposing in the bin, right? Get the words like in the bin. Oh, we have t equals 15 days, right? Okay, so that's B. Let's move on to C. Redraw the space. C says find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin. Okay, so in other words, we have to figure out when our graph reaches a certain value, right? When is this graph going to hit the average amount in the bin? Well, the first thing we want to do is find the average amount in the bin. And I tell you what, I'll redraw this rectangle so that I have a little bit more room to see the calculator. All right. So here's where we're going to do average value formula. If you recall, the average value formula for the function f is 1 over b minus a, integral from a to b, f of x dx. So we are just going to apply this. Here's what we would write on the work. We would say 0 to 30, right? So we would say 1 over 30, integral from 0 to 30, a of t dt equals, and then at this point we're going to go to the calculator and use magic button to get the actual amount. So this time we got to go 0 to 30, so let's make sure our window, come on. I seem to be having difficulties. Oh, gotta turn it on. Let's make sure our window is set to 30. Sorry about that. We'll set it to 31. We'll give it a little bit extra room. And we can set this to -1. Really, 0 to 30 would be fine. So here we go. We're going to use, this time, we're going to use the integral feature of the calculator to work this value out. Like I said, no need for antiderivatives or any of that. Let's give it a moment. We go 0 to 30. And then we get that incredibly satisfying sensation when the calculator integrates and finds the value of the area, which is 82.579. So let's say this is 82.579 over 30, which is approximately, let's see here. I think in the calculator what you can do is even just kind of go and hit the divide by 30 button. And that way you don't have to do any rounding, right? It's going to take that answer from the screen and type it in for us. So we've got, that's 2.753. So that's the average value. We did the average value formula to the A function. So on average, this is how much grass in pounds is in the bin. Now we just have to find the time at which this is true. So I think the easiest way to do this, we could write it out as a work. I don't think you have to write this. What we're going to do is set A of t equal to 2.753. I don't think you have to write that out. It's just one of those things that you can write it. It's not required, but it looks good. What we want to do is go into our calculator, and the easiest way to solve this type of equation in a calculator is to go to the y equals menu, which I'm struggling to do. Go to the y equals menu, type in the value that you want to solve for as its own constant function. So 2.753. And then we are going to use the intersect feature of our calculator to figure out what time that happens. Now notice the black space is still kind of there. That's because we didn't do any redrawing. Don't fret, it's all going to work out. I'll tell you what, in the interest of being clear, I will, if I remember where, oh, well, here's another thing we can do. If you tweak your window and it has to redraw everything, it'll wipe that space out. So we're going to go to the intersect feature. I deleted -1 from the left edge of the window. So we have our intersection. Looks like it's going to be somewhere around 10 days. Let's go first curve, second curve, and then our guess. Somewhere right around there. Turns out I think it's going to be 12.413. So now we got our answer there. 12 t equals 12.413. And then always use units if they're units, so days. So how this problem would be graded is you would have to do the average value formula. There would be a point for knowing the average value formula, and then there will probably be 1 point for then identifying the correct solution. How, writing things like this out or writing, copying this picture onto the screen aren't really necessary. All right, we got one question left, which is D. D is basically going to be a tangent line problem. I'll go ahead and tell you in advance. And once again, we're going to use our features in our calculator. So typing that into the y equals menu at the very beginning, it was a good idea. So in this story, as it turns out, this function does a great job modeling the amount of grass on this domain. But once you hit day 30, according to the prompt, a line is a better fit for what happens than that exponential function. So we have to use the linear approximation. This was one of those orphan topics that we did one day, but linear approximations are just another word for use the tangent line. Right? Use the tangent line to make a prediction. So step 1 is going to be find the tangent line. So we need to find y equals mx plus b. Since we have a graphing calculator, this is actually going to be pretty easy. Our value m is going to be our rate of change. It says at 30, right? So we need to know the instantaneous rate at 30. So let's take our calculator and find our instantaneous rate of change using feature 7. Let me go ahead and delete this function. All right, feature 7, number 6. I'm sorry, feature 6. Feature 6. Feature 7 is integrate. Okay, so let's type in our 30. So first we know that y equals negative 0.0, and then let's kind of be good rounders. Let's go 0.56. We know that that's going to be our slope. Oop. That is our slope. Now we just need to find our b value by using an ordered pair. Now we have to use 30, right? We have to use 30 as the moment because that's where it's touching. So in case we have forgotten it, you should have it on the page. I cleared it off the screen, but you should still have it. We're going to go to our table set. We're going to jump to 30. It looks like it's still set. And there we go, 30 and 0.783. And here's the case, let's probably go an extra decimal. Those are going to be the values that we use. So 0.783, 7829, why not, equals negative 0.056 times 30 plus b. How much work you do in solving for b really doesn't matter. Honestly, all you're going to get graded on is do you get the rate of change, and then do you get the correct linear equation. So let's use our main screen here to do that. So we know we need to take negative 0.056, multiply that by 30. Then we need to add that value because it's negative. We're going to add that over to the points to the y value. That doesn't feel right. All right, so I tell you what I'm going to do. I don't want to have to redo the whole video, so I'm going to just do a rework of this problem. It's going to be a part 2. Sorry about that.